looking at question 1 on the circuit sheet that I gave you. We're going to use our techniques that we've been talking about to try and solve this one. So the first thing we have to do is find out if there are any parallel components in the circuit. So this is the parallel bit, this bit, right? Because these two bits are parallel. Right, so our first job is to replace these two with a single resistance, which will then be in series with this one up here. Right, this question's a little bit different to what we've been doing because we've got K in the units, so that just means by 10 to the 3, 1,000. So for parallel, we've got 1 on R equals 1 on R1 plus 1 on R2. So we've got 1 on 6,000 plus 1 on 12,000 equals, and remember that our x to the negative 1 button is our friend for this sort of thing. So I've just got 6,000, 1 on plus 12,000, 1 on equals, and then we're going to do 1 on the answer, which will flip it up the other way for us to give us the resistance is 4,000. Alright, so we can replace this with a single 4,000 ohm resistor. So what we'll do is redraw it. Alright, and we're going to put a single 4,000 ohm resistor in here to replace that section. And we've got 2,000 up here. Right, 2,000. Righto, so we're looking to find the total resistance of the circuit, or the effective resistance. So now that it's in series, we're just going to use R equals R1 plus R2. So we get 2,000 plus 4,000, 6,000. Righto, so we're going to, now that we've got the total resistance, that's the total for the whole circuit now, and we've got the total voltage is 150. So that means we can work out the current that's flowing out. Oh, wrong way. We can work out the current. V equals IR. I equals V over R. So we have got 150 over 6,000, which is a quarter, isn't it? I think so. 50 divided by 6,000. Oh, it's not a quarter, it's a 40th. 0.025 amps. So that's how much is going to be flowing out of the battery here and going through this resistor. Righto, then it wants the potential drop across each resistor. So we've got the current that's going through here. We're going to be able to find a potential drop across here. We're going to take that voltage, the potential drop is the voltage, away from this one, and that will give us the potential drop across this parallel part. All right. So we're doing, that's part D. We've already done A, B, C to get to here. This was C. Right, D. So the current in the circuit we know is 0.025 amps. We've got a 2,000 ohm resistor. So V equals IR. Should be 50, I think. Yep. 50 volts. So 50 volts would be across here. That means there's 100 across this one. So 100 across. So we have got across. Oh, forgot to move the camera down, sorry. Across. This is across the 2K ohm resistor. So across both the 6 and the 12, because it's the same across both of them, it's going to be 150 minus 50 equals 100. Just want to check something. Right, now the other way you could do that, I just double checked it, is to just use this value here. 4,000 times 0.025 is 100. So you can take it off the total, or you could calculate it as though it was just going through this one resistance here. Either way, you're going to end up with 100 volts for the 6 and the 12. Calculate the current through each resistor. Alrighty-go, so we know the whole current goes through the, so the whole current goes through the 2 kilo ohm. Right, so that's 0.025 amps. This one we can do, looks like we can do shares fairly easily. 6 is to 12, this one is to 2. So I need 3 shares. 1 share is going to go through the 12. That's making a mess, I know. The 12 ohm resistor is going to get 1 share. This kind of crosses across. 1 share, which will be 0.025. The total amount divided by 3, which is going to be 8.3, I think. Oh, I forgot to put in all the zeros. Duh. 0.0083. And the 6 ohm will get 2 shares, which is that times 2. 0.0167 amps. And that's it.